Hefe gonna give it to you. Let's get started. We're gonna do 4.3b. This is on locating critical points. So maybe I'll zoom in over here on the example before we look at the graph. Our first example is f of x equals 1/3 x cubed minus 7/2 x squared plus 10x. What we do is we take the derivative. So here we're taking the derivative of that. We get 3x squared, derivative of x squared, we get 2x, and x is a 1. And so I was just showing each substep there. When you clean it up, you get f prime of x equals x squared minus 7x plus 10. You set that equal to 0 to find critical points. So we can factor it to x minus 2 times x minus 5 equals 0. We use the zero product rule, go down each branch, and we get x equals 2 or x equals 5. Those are our critical points. We also check for where it's undefined. Is this undefined anywhere? If you said no, you're right, because that is a polynomial, and polynomials are continuous everywhere, which means it's not undefined anywhere. Okay, so we've got our critical points: x equals 2, x equals 5. And I graphed this in Desmos. This is the graph of that curve, and we can see that we have a local max. Notice that this is at the x equals 2 value, and we have a local min at the x equals 5 value. And notice I have these values there. I gave the coordinates of them. Okay. It's worth noting the local max here equals 26 over 3. It's not the 2 part. And the local min equals 25 over 6 at x equals 5. In 4.5, we'll learn how to confirm that these are actually critical points, or that these critical points are actually the local extrema, the local max and local min. We're not there yet. We just found the critical points, okay? But it did have, we needed the 26 over 3 and 25 over 6. How did I find those values? Think about it for a little bit. I'll answer it a little bit later on. I want you to think about it for a little bit, though. Maybe even pause the video and figure out, how did I get that value and that value? Okay. All right. Our next example we'll look at, I want you to try doing it on your own. So we're going to have f of x equals the quantity x squared minus 1 to the 5th power. Find the critical points. And pause the video, give yourself a second to work. All right, I'll assume you did. We take the derivative. Remember, this is a chain rule. Bring the power down. Lower the power. Oh, shit, I didn't lower the power by 1. Ah! Hefe fail. Need a 4 there. It's not going to change my answer. Like this. Well, I guess it changes the work, but not the answer. So we have 10x times the quantity x squared minus 1 to the 4th power. We set it equal to 0. We're using the zero product rule. And I notice I factored the x squared minus 1 to be x minus 1 and x plus 1. We will have critical points at x equals 0, x equals 1, and x equals -1. Okay? And I got a graph of it right here. we will see when we get to 4.5 that we do have a local min. The local min is right there at x equals 0, and it has a value of -1. But the other 2 points, these points right here, are not local extrema. Okay, well, and we'll see that when we get there. 4.5 will help us figure that out to be true. Again, how did I find out that this was 0 there, 0 there, and -1 there? I hope you've figured it out. We'll talk about it after the next example. Give this one a try. F of x equals x over the quantity 4x squared plus 1. Pause the video, work it out. You're taking the derivative, you're setting it equal to 0 or looking for where it's undefined. All right, I will assume you did it. I did the quotient rule because I wanted it all as one fraction. And if you do the product rule version, you have to get a common denominator. It actually takes a little bit longer when you need the common denominator. So the derivative of the low is 8x. The derivative of the high is 1. And I've got low d high minus high d low over low squared. I didn't actually show that part there. But this top part is 4x squared plus 1 minus 8x squared, which takes us down here. Maybe I'll move this a little bit. Top. So combining the 4x squared and the negative 8x squared, we get a negative 4x squared. So is this undefined anywhere? The bottom cannot equal 0. I actually talked about the 0 part first. So f prime of x equals 0. A fraction equals 0 when the top is 0 and the bottom isn't. Can the bottom ever be 0? No. For all x, remember, this means for all. For all x, it doesn't equal 0. And you can see that if I do a little side work here, get a little bit of a side hustle going on. If I set that equal to 0 and solve, I will find I don't get 0 anywhere. Take the square root. If I do that, I get 4x squared equals -1. This is always positive on the left. And the right side is negative, so it can't be true anywhere. Okay? So we don't have it undefined anywhere, but we can figure out where the fraction equals 0. We set the top equal to 0. I added 4x squared to both sides, and then I took the square root. You could have done this, divided by the 4, and then taken the square root. But this is a little harder to recognize that this leads to that. They both get you there. I think it's easier to take the square root when there's no fractions, because the square root of 4 is easier to find. This is, if you do the left one, don't grab a calculator. This is square root of 1 over square root of 4. So hopefully you can recognize that that is 1/2. All right, so we had our original function. I graphed it here. You can't see it because the graph would go on indefinitely, but this keeps going to infinity that way. This keeps going to infinity that way, but it never equals 0 again. It doesn't, it keeps going up, but never, we know it doesn't have another point where it changes direction. it's approaching 0 at the endpoints. And we'll talk about that more when we do limits at infinity. I think that's 4.6 or 7. Talk about that soon. So I found the local max and local min. The local max is 1, 4. Oop, wrong color. I still see a little bit of yellow there. Okay. At x equals 1/2. And we have a local min of negative 1/4 at x equals negative 1/2. How am I finding those points? All right, so I said I would say it. Let's talk about it now. To find this negative 1/4, you just take the negative 1/2 and you plug it in to right there. You plug it into your original f of x. So maybe I'll write it right here. To find the y values, plug into your f of x, not f prime of x. F prime of x should give you 0 every time because that's how you found it. All right, so that was doing locating critical points. The next video will be doing locating absolute extrema.